Okay, so I have had some questions about the assignment. So I was thinking that might be a good place to start. We can go over what the assignment was, particularly on the SPSS problem and importing an Excel file, and on the on how to work with it then, and also on the that little chart, the histogram, that precedence chart. There's a little bit of confusion about what we were looking for there. So let me go into the homework. So we are recording. Yes. And I want to make sure the chat box is open. Okay, let me get into it. Okay, so let's go right into assignment number 1.
I have a question.
Yes.
Can be quick.
Yes.
Give us the assignment. We had to use the SPSS.
Yeah, there's the last 3 questions. You have to use Excel and SPSS to finish the last 3 questions.
I never got an instruction how to use it.
Okay, we're going to take a look at that right now.
Said, what's your name?
Aruna.
Aruna said, I learned what you did on for Excel.
Yep.
And then for SPSS, I spent days on YouTube
Trying to figure out the SPSS stuff. Okay, we're going to resolve that right now. Okay. Well, there was the last session we had here. I think we actually did a little bit of that, but not with this specific problem. But let me see what we can do with this now. Oh, you know, when I use my own desktop here, I can blow things up a little bit easier. Okay, so let's take a look at this. Let's start from the first question. Categorical variables, right? Important to us. We want to know what kind of variables they are. So let's see. Which of these? There's 2 of these are categorical variables, nominal variables. Which 2 you think?
When it's split, what is it? When it's split?
That's categorical. In other words, they're categories, names like country of origin, right? That's a name, for instance. Somebody popped in there and turned on their video camera. Okay. Hi. You have your video camera turned on. I think I can turn that off here. I think I can. Yeah. There you go. Okay. Yeah, I can make you the presenter. How about if we wait for a little while? I want to get through the homeworks right now, but I can make you the presenter so you can, if you want to ask a question out loud, or actually I can just turn on your audio. So, as a matter of fact, let me give that a try right now. See how that works. Webcam, audio. My HP, whoever that is. Let's see if I can't find you and turn you on. Attendees. What happened to attendees? Good. Hi, can you hear us? Oh, I got to turn on my speaker. Go ahead. You should be able to talk now. Hello? My HP? Okay, you're unmuted. You should be able to talk. Oh, you don't have a microphone. It doesn't appear that you have a microphone.
Can you hear me now? Yeah, it's already muted. Unmuted.
Okay, there we go. We can hear you. Did you have a specific question?
Actually, no. Actually, I finished everything today, so I submitted it. It's kind of very tricky, and it took me like 4 days to figure out everything.
Okay. The good news is when we get into week 7 or 8, you're going to look back at this and you go to yourself, why wasn't I able to do this in like 20 minutes? You know, it's going to seem very simple to you. And I guess that's a sign that you're learning. You know, when as you progress in the course, the stuff that you looked at in week 1 and 2 and 3, and all of a sudden it seems very simple. That's a good sign, right? So I'm going to mute you. I'm sorry, go ahead.
Professor, the only problem is the software, the SPSS, is like, you know, I'm have a hard time when I touch the Excel and the SPSS together, and it knocked me out several times as it's not giving me the right answer. So I have to go back. 100 points.
I know exactly. I've had a few people bring that up, and that's exactly one of the things I want to cover. Right now, to start off with, I want to, right now, I'll get to that. Right now, I just want to quickly go through the homework, and we're going to get to those problems towards the end where you're having that issue with Excel and SPSS, okay?
Okay, thank you, thank you.
Okay, we'll get to that. Let me mute you now so we don't get an echo. Okay, so, all right, so I'm going to go down here. Okay, country of origin. Do you smoke? That's a yes or no answer. That's a nominal variable. That's a categorical variable. Country of origin. Simple, just so we can see what kind of variable is blood pressure. It's a numerical variable, right? In SPSS, they would call that scalar or a numerical variable. How about how many siblings do you have? That's numerical also. It's a special kind of numerical called discrete because it happens to be a small integer. You can forget about discrete. Nobody really uses that for anything. It's really a numerical variable. How country of origin? How about how many cups of coffee did you drink this week? Numerical variable. How about how would you rate the MPH program? Excellent, good, fair, poor. That's an ordinal variable. It's a type of category, good, fair, and so on and so forth. But the categories, the values for the categories have order. One is greater than the other. You can't say necessarily how they compare to something else, but they're not specific quantities, but that one is better than the other. The classic version of that is the pain scale. If I ask you how much pain are you in, you might say 3. And I ask you, here, take this pill. How about now? Oh, now it's 2, right? It's less than it was before, but there's no real number that 3 versus 2 could be different for other people. You just know it's less than the other value. You're going to ask a question.
Yeah. Ordinal would be a subcategory of categorical.
Yeah, I would call it that. Just like discrete is a subcategory of nominal. Okay, orange country, how many whole cups? There's one more that's a little bit different. How about what are the last 4 digits of your social security number? It kind of looks like it's numerical, but it doesn't mean anything as a number. It's really an identification, like a name. So that would really be nominal, even though it's like mine are 9736. But that number doesn't mean anything. All it means is an identification. So it's really, even though it looks like a number, it's really a nominal variable, right? That one's a little bit, I'm bringing this up because there are a couple in here that are a little bit tricky. How about blood lead level for a child in micrograms per deciliter? 1.93 micrograms per deciliter, what would that be? That would be numerical, right? That's on a scale, scalar or numerical. How about, I asked you before, how many cups of coffee you drink in a week? How about what's the average number of coffees that you drink in a month? Is that still a discrete variable? Maybe not. It could be like 7.3, right? That's kind of like more like just no longer a discrete variable. It's an ordinary numerical variable. Yeah, that's right. Unless you say whole cups, then it's discrete. Exactly right. Okay, good. All right. I think the rest of these are pretty straightforward. But you can go through that. When you answer them, they'll give you some feedback on whether you got it right or not. The only downside with Blackboard is that there's no way for me to let you back in to do the homework again without having you do all the questions again. So when you want to resubmit, when later on, it might be a good idea to record your answers. So that, if there's problems that you had no issue with, that you completed, then you don't have to, when you've got to go back and just make sure you get number 7 right, but you got wrong or something like that, you don't have to do them all over again. Okay, just like a little hint on that. But there's no way around that for me, at least that I've been able to find so far. Okay, now let's talk about this histogram, presidents.pdf. Okay, I got a lot of questions about that. It represents the age and inauguration of 44 presidents. By the way, where is Clinton or Trump going to be on that list when they're elected? One of the two of them is going to be elected. Where are they going to be on that list? Anybody have any idea? How old is Clinton?
69.
70.
70.
Any other president in history at their initial inauguration when they're elected? Even Reagan 68. Was not that old at his first inauguration, right? So pretty interesting, right? Both candidates. Both candidates from New York. Both candidates are the oldest candidates that would be inaugurated at their age for the first time. Right? So interesting kind of, I don't have to tell you, it's an interesting election in general. But it's particular. It's got a lot of peculiarities, not just the people that are running. So at any rate, histogram provided in the file represents the ages of 44 presidents at inauguration. Please answer following questions. Which range or bin, which group, which bar in the histogram represents the median age for presidents at the inauguration? What proportion of the 44 presidents were 60 years or older? And which range contains the 25th percentile and the 76th percentile? The reason why I'm kind of like saying that out loud right now is because I want to jump out of this and like open up that data file. Let me open that up. Okay. All right, so let me tell you what, even better yet, what I'm going to do is I'm going to go back here and I'm going to download it to my desktop. I'm going to right click or control click on the Mac, save link as, and drop it on my desktop so that I can open it as a PDF file. And there it is. Okay, so I'm going to take this one to the right, so we don't have to actually, it's faces there and stuff. So first question is, which bin would hold the median? What percentile is the median? The middle, right? It's the 50th percentile. In other words, half the presidents are younger than that, half the presidents are older than that. So out of 44 presidents, which president are we talking about? Roughly the 22nd, really with an even number. If you do 20, the first 1 through 22 are here, and then 23, 20. So there really is no middle number, right? So it really be the guy between the 22nd and the 23rd. But in this case, 22nd is pretty close. So we want to know where's the 27th oldest one. So the two youngest ones are in 40 to 44. There's two people in that bar. The next 7 presidents, youngest 7 presidents, are in bar B. So we've accounted for 2 and 7. That's 9 presidents, right? So the next bar is 50 to 54. That's 13 presidents. So between all of these, the first 9 are in A and B, and then 13 more. That would account for 20. That would account for 20. Let's see. 7. 24. Did I say 13? And 7 is 20. Is 22 would be exactly 22. Actually, tell you the truth, you could pick either C or D. Right? Because I just realized that it's between the two of them, right? So C or D would be the right answer there.
The rule says if the number is 2, if the 2 are even, they add them up and divide it by.
Exactly. So it would be the average of the 22nd age and the 23rd age, right? Which would. Oh, they're 20? Did I get? Oh, you're right. So it's going to be in D. Right. It's going to be in D. Right. You get why that's happening? It's because this represents two presidents. 7 presidents is 9. Did I get that? Did we get that wrong? 2, 7 is 9, and 13 is 22.
Yeah.
No, we had it right the first time. So yes, we can't really say 22nd or 23rd. 22nd guy is in C. The 23rd guy is in D. Right? Though these represent the ages of the president. So C or D would be the closest answer, or you could just say between C and D, right? But there's really, with a histogram, there really is no between. You got to be in one or the other, right? Because it represents ages. So I would accept the answer C or D as the right answer for that. And in fact, what I'm going to do, if it doesn't accept both, then I'm going to go back and change that. So how about if I asked you what the 25th, where was the 25th percentile? Out of 44 presidents, which age would be the 25th percentile? The 11th, right? The 11th. So this is 2, this is 7, so that's 9. So the 11th percentile is in, the president representing the 11th percentile would be in C. Okay? How about the 75th percentile? Which president would be 3/4 of the way up the age scale? That would be, out of 44, that would be the 33rd president, right? So am I going to count up from the bottom, 33? Well, it's going to be easier. I can count down from the top, 11, right? So what do we got? We got 3 in this first group. We have 7 in this first. We have 7 here, so that's 10. So the 11th president would be in the group D. 11th down from the top, or 33rd up from the bottom. Okay, are we comfortable with that? You see what the logic is there for, you know, where is that particular president in the order of all these other presidents? I'm eyeballing. I can see that it's like, you know, 13. Yeah, because it's like, it's easy to see because, yeah, because it's 13 or 14. So if it's not on the line, it's just one out. I don't know, maybe I can make this larger so you can, see what I mean? Yeah, it's pretty clear what the level is. Yeah, it's kind of an oddball question. Maybe next semester I won't use it. We've been using this a long time. Maybe next semester I won't use this because, you know, it makes do something a little bit more realistic. You know, but that's the idea there. It's so what does this train you to do? It trains you to understand what a histogram represents. This histogram represents the values, the distribution of the values for the ages of the different presidents. In other words, it doesn't represent the presidents themselves, it represents their age. So in other words, Kennedy was inaugurated at 43, so he's in A, 43. So the value 43 is in there. You know, I don't know who the other guy was. Maybe Teddy Roosevelt. You think? Yeah, but Obama's pretty young, right? Yeah. No, I don't think Clinton. I think Clinton was like in his late 40s. Yeah. Or I was thinking Teddy Roosevelt possibly. Although, because he was, yeah, I'm not sure if in the first inauguration means election, or he became president first time around because, was it McKinley was assassinated or whoever he was vice president for. But at any rate, yes.
You had larger data.
Yeah. Yeah, and
the program would tell us.
Yeah, exactly.
It's really simple. We can look at it.
Exactly. But yeah, this would not be practical if we were talking with a real database, like the 800 women that were involved in the North Carolina birth study. Okay, let's take a look. And there was one other question, which was, I mean, I think it was in a tab. Let me go back to this. Here we go. Okay, there's another question. It was, oh yeah, let's see. What proportion of the 44 presidents were 60 years or older at their inauguration? Well, 60. Well, I'm sorry. 0.23. And the way we got that was there were 7 presidents in this group and 3 presidents in this group, so it's 10 out of 44, which is a little under 25, or I guess 23%. Okay, so that's the deal there. Sometimes we ask another question, and that question might be, given that the president was older than 55, what's the likelihood that he was over 65? That's what they call a conditional probability. We're going to start that. We're getting that a little early, right? The reason why I didn't put that in here was because it's a little early for that. We're going to talk about that in the next 2 weeks. We're going to get into probability next week. Given that the president was over 55, so in other words, we're only concerned with the people in D, E, and F. What's the probability that he's over 65? Well, the people we're concerned with are 12 in column D, 7 here, that's 19, and 3 is 22, and only 3 of those presidents out of the 22. So that conditional probability, the probability is 3 out of 22. When we get into that, we're going to be interested in conditional probability because it comes up a lot in statistics, right? But this is just a quick example, a quick jump start on conditional probability for us later on. So okay, let's move on to the next thing. Okay. Oh, good. Who's HP anyway? Type in your real name so I can call you by your real name instead of my HP. Can you still hear me there? I think there must be a little bit of a lag. Oh, Gladys. Hi, Gladys. Thank you very much. So now we can call you Gladys instead of my HP. Okay, so I'm going to take a look at the next group of problems. Okay, which is, let's see. Okay, using the data provided in student test scores, XLS, use Excel to calculate the mean, median, mode, and so on and so forth, interquartile range, and so on. I just want to open that up quickly so we can see how I would do that in real life, not exactly the way I might necessarily do it when we demonstrated the first week when we demonstrated how to do these Excel calculations. In other words, doing this basic calculation from scratch. I'm going to drop it on my desktop again. And let me go back to the desktop. Here we go. Okay, so I'm going to open this Excel file. Okay, this is a file I don't need. I don't know what that is. This is the one I'm interested in. So I'm going to blow this up so we can see it better. Okay, good. So here are our 20 scores, right? At the top here, there is a value called scores, which is the variable name. That's the name of what these are. Maybe they're test scores, maybe there's some other thing, but the variable name is scores, and then the actual values are below that, right? So if I wanted to find the mean, median, and median, and so on and so forth, I could find the average. And I would use the actual functions in Excel rather than, do the way we did the calculation that previous time. Okay, so the average is, the mean or average is 77.77. The standard deviation. Notice I'm spelling that out. I'm not writing a sigma for mean or standard deviation. I might write an X bar. I might have called this X bar, or I might have called this SD, right? It's a sample that we're finding the mean and standard deviation. Population, we use the Greek letter like sigma or mu. In fact, let me see if I can't do that. Let's see.
So to find the mean, you put
Equals average. Yeah, it doesn't have a function that's called mean. It's average. I want to see if I can't quickly find mu. This looks Greek. No, this is Cyrillic. Here we go. Here's Greek. Let me use the lowercase here. Mu. Okay, did it put it in there? There you go. That's mu. And sigma. Let's see. Here we go. Here's sigma. Sigma and mu. Okay, if we're talking about the population, I would use mu for the mean and sigma for the standard deviation. If we're talking about a sample, I would use X bar, X with a bar over the top. I just wrote it that way for convenience. And SD for standard deviation. Standard deviation, we have a function. Oops. STDEV, parentheses. And I just do it for the same numbers again. And it comes out to that and a median, the middle value. And this is also another way of saying the 50th percentile. Right? Half the value is above it, half are below it. A little bit different than the mean this time, right? Since the mean and the standard deviation are different, that would indicate a little bit of a skew, right? We'll take a look at the data later on a little bit closer and see how that affects it. Okay, how about minimum and max? How about the range? The range is the minimum minus the maximum minus the minimum. Maximum, okay, is, I'm going to type in A2 through A21, I guess it is. So the minimum is, the maximum is 94 equals, how about minimum, MIN? A2 through, A2 through A21. Okay, and what's the range? The range is equal to the difference between the two of them. Maximum, biggest number minus the smallest number, and that's equal to the range. Okay, everybody comfortable with that so far? Okay, now we'll get somewhere where we're not comfortable. How about the percentiles, right, and the interquartile range? So let's calculate we want to know the 25th percentile and the 75th percentile. Okay, so first I'm going to do 25th percentile. Okay, I'll just put that in there. So that's going to be equal, there's a function called percentile. Percentile, parentheses. It asks me for two things to fill in that. One of them, let me see if I can't. No, it won't let me blow it up anymore. It asks me for the array, the group of numbers that I want to find the percentile of, comma, the percentile that I'm looking for. It calls it K. Now, I'm not going to put 25. I'm going to put 0.25. It wants it as a decimal value, 0.25. Close the parentheses, hit enter. Okay, so the 25th percentile is 72.75. What does that tell you? 25% of the values are below that. 25% of the values are above that. Okay, so let's try the 75th percentile. Okay, and what's that going to be? It's going to be equal to percentile. Well, actually, let me, before I do that.
And the 25th is 25 below and 75 above.
The 25th means, yes, exactly. Okay, now 75th percentile, 75 people are below it and 25% are above it. Like if you took the GREs and you were in the 87th percentile, that would tell you 87% of the people who took the exam scored lower than you, 13% scored higher than you. Equals percentile. And again, it'll prompt me for percentile array, which is the list of numbers. And I could do it this way by clicking in there and just highlighting, okay? Or I could just type it in myself, A2 through A21. Close parentheses. And then it wants K, right? And that's going to be, what is that going to be? 0.75. I'm going to hit enter. And there is our 75th percentile. So what is our interquartile range? Percentile, parentheses, array, the list of numbers, the range of numbers, comma, 0.25, point whatever it is, close parentheses. Here, I'll show you, if you look up here, equals percentile. And it'll come up as soon as you type in percentile and put in the leading parentheses, it comes up and it gives you a hint there. See it there? Right? Array and K. It doesn't seem like that'll blow up much. So it'll actually give you. So now the interquartile range, exactly, is equal to the 75th percentile minus the 72nd percentile is 9.5. What does that mean? That is an indication of how wide the area is that represents the middle 50% of the people. When we're in statistics, we're always looking for the middle, and we're looking for how spread out things are. So this gives us an idea of how spread out the middle 50%, the main group of people, the middle group of people. So it's kind of it has some value to us. So if I were going to create a box plot, right, the box would be from 72 to 82 would be the box portion. The middle of it, where this fat bar is going to be at 78.5 because that's the median. And those two little feathers, those lines that extend in those two little feathers, assuming that there's no outliers, those two little feathers would be the range. They would be at 57 and 94. So I could literally take a piece of paper and a pencil and draw a box plot from these numbers. Okay, and that's when we look at SPSS, that we'll see that that's what the box plots. Now I'm going to leave this. I'm not going to close it because we're going to go and take another look in just a little bit. Okay, when we look at SPS, when we try and do this again with SPSS. So the problem asks you to calculate a bunch of things, and then you put in the numbers, and it should tell you, if you're right or not. So let's see where we are with this. Let's see. Okay, that's question 7. Question 6. Yeah, 75%. I think we got everything. All right, variance. The variance, there's a value called the variance. You could say equals VAR, parentheses, put in the range, and it'll tell you what the variance is. But we calculated the standard deviation. If I know the standard deviation, can I calculate the variance? Remember what it is? It's the square of the standard. You get the standard deviation by finding the square root of the variance, right? So you can find, if you got standard deviation, you can square it, and it'll tell you what the variance is. Okay, minimum, maximum. I think we got everything there. Okay, so let's take a look at question 7. Okay, and good work, Grace. Grace is keeping up with us there. Okay.
Standard deviation squared.
Okay, Thomas. I guess Thomas can't see the screen. Thomas, log out and log back on through GoToMeeting and see if it works out for you. Okay, you should be able to see it, but we are recording it in case you have a problem with it. Okay, good. Just checking, see if we're still recording. Okay, so now, let's see. Let's take a look now. Okay, so now, next problem. Repeat the calculations using the same data, but do it in SPSS or R if you wanted to, or SAS or whatever. You could use whatever. As far as I'm concerned, you can use anything you're comfortable with. You can use. We're basically going to rely on SPSS for the class. So in order to do that, I need to get that data into SPSS. So I'll show you a couple of ways that I can do that. I mean, the simplest possible way for me to do that, I'm going to open up this file again. I'm going to go in here and I'm going to say copy. I only copy the numbers, notice, and Command C. Okay, and I'm going to start SPSS up. Okay, it'll bounce around for a little while. And we could have a cup of coffee, have a little donut. SPSS has been around for a couple of decades, at least more than a couple of decades. And rather than rewrite it from scratch, it seems they incrementally fix things and update them, which is good because they do frequent updates. They do an update every year almost, right? But the downside is that they never really rewrite the thing. So the code is old and slow. So now I'm going to close this. I don't use this opening window at all. So now I'm in my variable view. I got to click into my data view. Here's my data view. I'm going to click into the number 1 and I'm going to say paste. And it's going to paste those numbers in for me. So I've taken that data from SPSS and I've pasted it into the data window from Excel into the data window of SPSS. Perfectly okay, right? And now I just copied in Excel. I just highlighted all the numbers, said copy, and then went into the first cell up here and said paste. I could do it again in the next one. Also, I'll just do it again, just like that. Same numbers are in there, right? It's really Excel thinks SPSS now thinks we have 2 variables. I could actually undo to get rid of that. Okay. So now the only problem is that it changed the variable. Since I didn't tell it the variable name, it assumed it needed to make one up, so it called it VAR001. I'm going to go into the variable view and change that. Okay, so I'm going to tell it, oh, the variable name was score. And it's a numeric variable. It got that right. It recognized that. It said, oh, let me get rid of that. I'm going to clear. That second line, I don't need it. It's a numeric variable. It recognized that correctly. It says, I'm going to give it 8 decimals wide. Okay, there was only 2-digit numbers there, so that's plenty. 2 decimals. We don't really need any decimals. They were not decimals, but it's okay. I'll just leave them there that way. And it doesn't have a label. A label is an opportunity for me to give it a name that's more descriptive than the simple variable name. So I might say score on midterm, okay, or something like that. So now, whenever SPSS creates a graph or a chart, instead of just saying score, which is not very descriptive, they'll say score on midterm. The variable name score, the variable names have a lot of limitations. They can only be a certain length. They can't have any spaces or special characters, and they can only be letters and numbers. Okay, and they got to start. It has to start with a letter. So at any rate, I'm not worried about missing values. There's no missing values. On the display, it's giving it 8 columns. This part over here refers to how it displays. So it's 8 columns wide. That's okay. That's plenty. The alignment, I could change it from left to centered. Doesn't matter, whatever I like about it. So I'll change it to centered. Okay, now under measure, it says unknown. That's the variable type. We know that variable types are important in statistics. One of the reasons why they're important is because we only do certain kinds of operations with certain kinds of variables. Like if it's a nominal variable, we know bar charts, frequency tables. If it's a numerical variables, we know we want to work with means, median, standard deviations, and so on. Those are kinds of descriptive statistics. So I want to make sure that SPSS knows it's not a nominal variable, not an ordinal variable, but it's a scalar or numerical variable. So that way it'll handle it properly. So I'm going to go back to my data view. And now at this stage, I've imported the data and I can actually work with it now. So when I want to do an analysis in SPSS, like for instance, I want to find all the things we just found before for this data, I go up to Analyze, simply enough. Analyze, it's descriptive statistics. Frequencies is what I would use for nominal variables, like just wanted to count things, number of males, number of females. Descriptives is, or an explorer, what I want to use for numerical variables. So if I use descriptives, it opens up a table, which almost always happens at SPSS when we choose an analysis technique. And it tells me the variables I have, there's only one. So there's only one in that table. And it gives me the opportunity, if there were more than one in that table, it gives me the opportunity to choose which one I want to work with and move it into the variables table. Now, I can go into options and I can tell it, oh, gee, I want to calculate the mean, standard deviation, minimum, maximum, variance. I don't see interquartile range in here. It's not offered as one of the things I can work with, right? Or percentiles. So I'm going to say, okay, but I'm going to go ahead and do it anyway. When I click OK, SPSS is going to do this calculation, same one we did in Excel. Okay, and it's going to calculate. The minimum was 57, the maximum was 94, the mean was 77.7, the standard deviation was 8.45, the variance, these should be the same numbers as we got when we did it in Excel. Okay, are they? You guys remember? Should I open it up? Let's take a look. 57, 94. Mean is 77, 8.45, median is 78.5. I don't think you found the median, did it? No. Standard deviation is variance. So it's the same numbers we got in Excel, basically, right? It did it a little bit quicker. So now, if I want more extensive statistics, I can go into Analyze. Instead of going for descriptives, from descriptives to descriptives, go from descriptives to Explore. And once again, move the variable you want to work with into the main area here, the dependent, and call it the dependence list. If you click on statistics, it's going to say, oh, I'm going to calculate a lot of descriptives for you automatically and a confidence in 95% confidence interval. We're not going to get to that for a few weeks, so you don't have to worry about that. So I'm going to say, that's great. Go ahead and calculate the descriptives. Oh, look, there's a plots option in here. Well, you know, it's going to calculate something called a stem and leaf plot. Not very useful. I'll leave it turned on. But it'll also calculate a histogram for us. Secretly in the background, it's also going to do, always going to do by default, a box plot. You don't have to tell it to do that. So I'm going to click Continue, and I'm going to click OK. So I know I'm going a little bit quickly here, but you know, I know that you can go back after we record this and go through this a little bit slower. Right? So if I'm losing you a little bit, keep in mind. Okay, yeah. The count. Now take a look at what we got. This time we got more information. We got the standard minimum, maximum range. We got the interquartile range. It gave us the interquartile range. So we got more information than we did before. We got a histogram. This is the distribution of the values that were in that table, right? And it looks fairly normal. Maybe it's skewed a little bit because this guy's a little lower than the others, but it looks pretty normal. And what about a box plot? Here's our box plot. And what's in our box plot? Well, the median is about 78. Here's the interquartile range between about 74, it looks like, and about 82. And here's our maximum value. And wait a second, our minimum value, there was a value in there that was so low, so much lower than all the other values that SPSS highlighted it as an outlier. Potentially, maybe there's an error in that value because one of the scores was so much lower than the others. Now we can go with, right now, let's accept that. Later on, we can redefine what an outlier is if we want, you know, for our own purposes. SPSS is just using a calculation that estimates the value of the interquartile range and how far that is from the interquartile range. I think most of the time it's anything that's more than 1.5 times the interquartile range from the next highest value or something like that, or the top of the 75th percentile or below the 25th percentile. It defines that as an outlier, right? It uses some formula, right? But the formula is arbitrary because outliers are really a judgment you have to make later on about, gee, is that really low because it's an error or a value I really shouldn't consider as part of my analysis, or is it just that that's the way the data is? There's just so much of variability that we might have a very low score or a very high score. Okay, so it does that for us. Yes.
So you have the graph here, and how
Exactly.
But like, let's say we're using large quantities of data and we're using decimals.
Yeah.
You wouldn't be able to like eyeball.
No, not really. So then you would go back to the chart here, and you could look up the median and the 75th percentile. Yeah. The median 78.5. It doesn't let me blow it. It's unruly. It's not a Mac like or a PC like. It says 75th percent. It says, where is it? Oh no, this just gives me. Yeah, it doesn't give me the percentiles, does it? That's a good question. Yeah. Yeah, I think we can get the percentiles here. Let me see what I would have to do. Analyze, descriptive statistics. Let me go into Explore, see if I have any other options. Nope. Statistics. Here we go, percentiles. I just didn't turn it on. Okay, and let's see what it does this time. This time, it gives me, here you go, it gives me all the percentiles. 5th, 10th, 25th is 25th percentile, 50th percentile, that's the median, right? There's the 75th percentile, 82.75, and so on and so forth. Dirty little secret, it calculates it a little bit differently than Excel does, so you may not get exactly the same value for all of the percentiles, particularly for the median sometimes, or the interquartile range sometimes. But don't worry about it, it's usually a minor difference. Okay, so that's basically, that's one way for me to import the data from Excel into SPSS, just simply copy it and paste it in. But then I have to, that can be a little cumbersome if it's a really big data file. So what's another way for me to do that? Okay, so another way for me to do that is to say open, and say open data. Now I'm going to navigate to where the Excel file is. I know it's on my desktop. So I'm going to click in here, go to the user, Tony DeVito, go to my desktop. It's here somewhere, desktop. And I don't see the data. I don't see the Excel file there. The reason why I don't see the Excel file is because right now SPSS is only looking for .sav files down here. So I got to click on that and tell it to show me Excel files also. Or if I want, show me all files, right? So if I tell it to show me Excel files, now suddenly I'll be able to see not only the other files, not only the folders, but also the Excel files. And here's the Excel file I was working with. Okay, I'm going to double click on, I'm going to say open that. It opens a window which says, okay, this is what I see. I see data in the data sheet from in cell A1 through B21. Well, wait a second. There's only data between A1 and A21, not B1, right? I had nothing in the B column. Problem there is there must have been like a space or something like that, or maybe even a period. There might have been some extraneous junk in the B column. I'm sorry.
You wrote it next to that column, the average.
Oh, you wanted to, yeah, as a matter of fact, there you go. There's other stuff in that file I don't need, right? That's a problem. See, what happened is that I monkeyed with that file. I'm going to say, okay, and import it and see what it looks like. Okay. Oh, actually, no, there's just junk. This is the original file, right? Not the one that I worked with. This is the original file, right? So it imported, even put the value label score, the variable name scores up at the top. But somewhere, see these little periods in here? Somehow or other, there must have been like a little dot or something like that in the column, right? So I can either ignore that or I can clear it. Okay, it doesn't matter. So it imported, the first column is what I really want. Now, one of the issues that we had was that there's a couple of versions of the Excel file that I put on Blackboard, including an answers file. Let me go, let's see. Let me go to Firefox, and let me go to where the data was. Here, there's a couple of versions of this Excel file, or maybe, you know what, it might have been two. People might have been using, here, let me go to Excel. Let me take that file we were just working with all this extra stuff, and I'm going to say save. Save as, and I'm going to give it a name, done. Name done to the name. Now, if I try and import that one into SPSS, watch what happens. Open, data. Okay, change this to Excel so we can see the Excel files. Okay, I'm going to try and import that one to Excel. Okay, A1 through E21. Well, when I import that one, look, it imports all that other junk too, which I don't need. It imports all this stuff, which I'm not interested in because I'm going to calculate that anyway. I could deal with that a couple of ways. One, clean up the Excel file, or just go and say, select all those extra columns and say clear, erase it. Oh, didn't quite do it, did it? Try it again. There we go. So they're gone. So now I can work with just that one column. Okay, so there's two ways. That's two ways that you have that you can import Excel data into SPSS. You can just simply copy and paste, or you can actually import the file. But in order to import the file, you got to make sure you know a little bit about it. I'm going to import it one more time. Open, data. Okay, and I'm going to go change this to Excel so you can see the Excel file on the desktop. And there's the Excel file there. I'm going to see the original file. I'm going to say open. Again, it says A1 through B21. I could actually type in here, just import A1 through A21. I can tell that I only want that part of the sheet, right? But what about this little check mark here? Read variable names from the first row of data. Should that be checked or unchecked, do you think? Checked, right? Because that first row of data had the name of the variable, didn't have actually a number. So what happens if I uncheck that? It's going to think score is part of the data, right? And it'll import it like as if it's a number, right? And we don't want that. So we want to make sure it knows that that first thing in that column happens to be the name of the variable. So, and then I put A1 through A21. You don't have to do that, but I'm thinking that it's going to avoid pulling in that extra column, which has really nothing in it. Let's see if it works. And bingo, it worked. Okay. When you're here, you may want to go into the variable view, because anytime you import a file from Excel into SPSS, it does not do the coding for you. It just tells you the variable name if you had it, and then you have to make sure that it correctly identifies as its scalar. You did that correctly. And if you want to give it a label, like a more detailed label, like score, score for Nick, we're in Brooklyn, we're in Manhattan. What am I saying? Nick's, right? Nick's score or something like that. You can put that in there, and that'll define that in the tables that you use, that you do. Let me just show you that while we in the output table. Remember, the variable name was scores, but if you look at the data, if you look at the charts, it calls it score on midterm. If you look at this, the average score on midterm, it doesn't use the value score, it uses score on midterm. Okay, so that's how we would pull this into Excel to answer those additional questions. Now let's take a look at the next question. Okay, how are you guys online doing? Okay, let's see. Where's the tab now? I'm going to get into the right tab here so I can read the other question. Nope. Here we go. That was question 7. Yeah, analyze descriptive statistics explore. Okay, question 8. Using the North Carolina 800 mod, I think they're all the same files, those, or ncbirth800.csv. Who knows what that .csv file is for? .csv is comma separated, I think variable, comma separated variables or something like that. Comma separated is for sure. That's what you use if you're using R. R uses comma delimited or comma separated files. So if you're using R, you would use that file. If you're using SPSS, you would use the .sav file. Okay, so compare the mean, median, and standard deviation of the weights of infants in grams born to women who were married versus women who were not married. So compare, we want to create side-by-side box plots, and we want to copy the appropriate tables into a Word document and upload that document. Okay, so, let's see. Hint, SPSS analyze, descriptive statistics explore, just like we used before. So let's open that data file. First thing I'm going to do is I'm going to go back here and I'm going to download it to my desktop, the .sav file. And I'm going to put it on my desktop. There it is. Okay, and now I'm going to go into SPSS. And I'm going to say open data. I'm not bothering to close the other files. And look, here it is right here. We could see it immediately. Why could we see it immediately? Because SPSS is looking for SAV files. I didn't have to change it to Excel files. It knew it was going to be there. Okay, so I'm going to say open. And it gives me a little warning. You're going to see this on a lot of versions. They changed the way that they interpret text or store text in the computer between different versions of SPS. They changed in version 16. But I guess they had some issues. So now, whenever you open a file or when you install it, it asks you if you want to use something called local encoding or Unicode. Ever since version 16, the default has been Unicode. But it doesn't matter. We don't really care about that. Just whatever it suggests, just click yes, and it'll work fine. Okay, so you don't have to worry about that. So here's my data view. And this file has a lot more information. First of all, it's got 800 subjects summarized here. And it's got 2, 4, 6, 8, 10, 12, 14, 15 different variables associated with these.
I couldn't find the ages.
You couldn't find the ages? Okay, let's take a look. M age, right? That's the mother's age, right? M age. I know, it's frustrating. And you want to know something? That's a perfect example of why you want to have a label also. If I go to the variable view, right? If I go to the variable view, now you got to be a little bit careful here. If I can click in at the top, see how it turns into a little cross with arrows there? I can click down and drag this apart. You got to be a little bit careful because if you select more than one row, it gets really weird. Okay, so if you look in here, M age, that's the same thing. The label describes that better. That the variable name is M age. The age of the mother is the M age is described better here as the age of the mother in years. Okay, so and what about the marital status? Here's the marital status. Marital stands for marital status. Okay, now the age of the mother is a numeric variable, and if I look over here, SPSS got it right, it's scalar. Okay, the marital status is a nominal variable, category, married or unmarried. So now if I go over here, it says marital status, that's a better description. But if I go over further, in age, there was nothing listed in values because the value is just a number. But when you have a nominal variable, like marital status, you can click in there and the little box appears, you click that and it'll tell you or give you the opportunity to define, well, 1 equals married and 2 equals not married. Now, that's because the data was input as a number, right? But you want SPSS to know what 1 and 2 equals so it can use that in the charts. So, okay, so let's see what we're going to do here. We're going to say analyze, descriptive statistics. So what do you think? What should I choose there? Frequencies, descriptives, or explore? Opinion? Only got 3 choices. Well, if I do descriptives, that's fine. I can get the age of the mother and put it in here, and I can find the mean age, the standard deviation, and so on. I'll do it. But I won't get the plots, and I also won't be able to separate the married mothers from the unmarried mothers. I'll just, there you go. Now, perfect, exactly. So I'm going to go to analyze, descriptive statistics, Analyze, descriptive statistics, explore. And when that comes up, I can put in the age of the mother into the dependents list, the main area I'm going to work with. But then I can put another variable in the factors list. That's going to be a categorical variable, something I want to divide this up into, what groups I want to divide it up into. So I could put in the race of the mother. I could put in any category, whether the mother smoked or not. If I wanted to know the age of the mother, the average age of the mother, smoking mothers versus non-smoking mothers, I'm willing to bet older mothers were more likely to be smoking mothers than younger mothers, right? Just different generations, I guess. Okay, so, but if I want to know the age of the mother relative to whether or not she was married, is that what I asked? I don't remember what I asked. Is that what I asked for? The average age? Okay, age. So age of the mother, but I want to factor it by the marital status of the mother. Right? You notice that it's you can tell because it has the 3 different colored balls, and that represents a category. Move that in there. Now it's going to calculate all those statistics for the age of the mother, but it's going to separate it by those 2 groups, married and unmarried. So statistics, I'm going to go in here. Sure enough, I'm going to check percentiles. What the hell, right? Okay, I'm going to click on plots, and I'm going to say, well, give me histograms for them as well. Okay, and I'm going to say, okay, display both the statistics and the plots. I'm going to click OK. SPSS is going to crank and work. And sure enough, here we come. First, it tells us the summary of all the cases, right? 537 women in this group, in this sample were married. 203 were not married, right? Okay. And if I can't tell you how much a difference that is between when I was a teenager and today. Right? I mean, in the 60s or something like that. Well, 60s, but in the 50s, that'd be like, that would be unthinkable that more than a third of the women would be unmarried in North Carolina. Well, I don't know, maybe, who knows? At any rate, things change. The mean age for married women was 29 years old. The mean age for unmarried women was 22. Wow, that's quite a difference. Right? Whether or not that difference is just chance or is really statistically significant is something we're going to be looking at for the rest of the semester. Understanding whether, when you get a difference in 2 groups, whether or not that's a real difference or not. Okay, so we've got the mean, we got all these statistics calculated for the married women, all these statistics calculated for the non-married women, we got percentiles for both, and we got a histogram for the ages of the married women. Histogram for the ages of the unmarried women. Look at the difference in the histograms. Isn't that interesting? The married women is relatively normally distributed. For the unmarried women, it's skewed. There's much fewer older women who are giving birth that are not married than there are younger women who are which is kind of, well, no, wait a second. I got that wrong. I have that wrong. It's skewed to the right. So this part is normal. But there are a lot of women who are unmarried who are choosing to have children at a later age, which kind of like fits in with what we know about society now, right? In other words, a lot of women choose that I may not be married, I want to have a baby anyway. So here it was very normally distributed, and here it's skewed to the right. There are a lot of women that are having a baby who are not married at a older age within a group of older women. Exactly. In other words, if I compared the mean and the median of this histogram are probably very close together. The mean and the median of this histogram are going to be different. The median is going to be here. The mean is going to be pulled higher, because these women up here that are much older than the rest of the group are going to pull the average up, but not change the middle very much. The middle value is going to stay. Yeah. Yeah. The mean is more elastic, is easier to change than the median is. Okay. And here's our histogram. And there's a lot of outliers here, and those are those older women that we're talking about. So you can see there's the mean for the 2, there's the interquartile range. So we can see there's a significant difference between these two groups. And you can even see that the median is not really in the middle of this box, which is another hint that the 50th percentile is all the way over here, but 50% of the women are in this range up here. See this one over here, the median's almost right in the middle. 50% of the women are here and 50% are here. It's a normal distribution. But in this distribution, there's a much wider range of the top 50% than there is of the lower 50%. That's that skew, right? Okay, so that's what we're after. Now, the only other thing that's a little bit tricky here is now we want to take this information and we want to give it to other people, right? So now the problem with that is I can go in here and I can save this. I can say save as, and it'll save it as a SPV or SPO, a SPSS output file. But a lot of people don't have SPSS, right? So they may not be able to read this data, right? So instead, there's a couple of things you can do. And one thing is to simply open up your word processing program, okay? And you can actually select from your output window, you can select tables and charts. Let me go back to the output window. Got a lot of stuff open now. And let's say I want to present this data to someone else. And I say to myself, okay, I want to get this all of this statistical data. I'm going to say copy. I'm doing it from the menu so you can see me do it. And go into my Word document. And I can say paste. Okay, and it copies that table into my Word document. What's that? Yeah, I managed to get it. I think I managed to get it to work. There's a few ways that it doesn't work, but you know, there's a few glitches I still have, but I managed to get it working a little bit better than the last time. So I'm going to go back in here. I had a little bug in mine. Let's say, oh, I want that histogram in there too. Command C on the Mac, and let's see if it works with my okay, hang on, no, it didn't work, but there's hang on, I got another way to do that, I think. Let me see what I need to do. Copy. And I may need to, did I get it there? Nope, I'm having a problem with but you know, let's see if oh, here we go. Maybe I can do it from here. No, I'm still having a problem. I'm having a problem with the graphics, but you should not have this problem. Yours should work out okay. You know, there was another way. Okay, the other thing you can do with this data file, I can say file, and I can say export. Okay, this is the output file. I have the output file open. Remember the input file, output file, two different windows. You got to save them separately. And I can export this to something called an RTF file, a rich text file, which is basically the same as a Word file. So I'm going to export this to an output file. It's on my. It's already going to my desktop. I don't have to browse. I'm going to say results. I'll call it results, and I'm going to say OK. Cannot see the folder you specify. Okay, let me browse. Go to my desktop, and I'm going to say results. Save. Okay, let's see if it works this time. Yeah, should be saving it. So if I go to my desktop now, I should see that file. And that file will have all of the tables and graphs, and you can cut and paste from there as much as you want. Yeah. I'm sorry. You know, no, you don't have to put it in there unless you want to. Unless you want to store it so you can go back and see exactly how you got. That's the nice thing about the syntax that it gives you is you can go back and read that and say, oh, this is the way I did this. Okay, or this is the way SPSS handled this. Here's the results. Let's see if it works. Cross your fingers. There you go. And there's all the tables. Everything that was in that output table is now in a Word document. Okay, I'm only asking you to give me the couple of tables that you need. Yeah, yeah, and from here it definitely works in the Word document. Or you could just delete all the stuff that you don't need. Yeah, export and then tell it where I wanted to save it. You know, it'll say RTF file. Okay, the last thing I wanted to cover with you guys, I don't know if I may lose you guys that are online here because I don't know that this will necessarily work. You'll be able to necessarily see this when I